Okay, I want to do this superposition example with a dependent source. This is a current controlled voltage source in this circuit, and we have to find I. So we're going to use superposition, but we are not going to turn the dependent source off in this example. So how we're going to do that is divide it into two subproblems, and then we'll combine them at the end. So the subproblems are going to be, the first one is going to have only the 24-volt source on, but as I said, we're going to leave the dependent source on. And what you'll find here, this is still a 3 ohm, this is still a 2 ohm. Because we're using superposition here, we're going to turn off the 7 amp source or turn its strength to 0, and as a result we'll have an open circuit where it used to be. And in the second example, we're going to turn the strength of the 24-volt source to 0, the voltage source to 0, and we're going to be left with only this 7 amp current source. And of course that dependent source. All right, so this is a very safe way to do it. It works, and we will see what happens. So if we do the analysis over here, this is a very simple analysis here to find I1, which is the current through that in instance 1. And so that's going to be 24 minus 3I, which is going to be the voltage drop from there to there, divided by the resistance from there to there, which is 5 ohms, and that's going to equal I1, the first case. The second case, we're going to be, again, looking for this. Now it's I2. So we're going to be doing, we'll do KCL at this node. So we're going to have actually, we know I2 coming into it. We'll do the currents coming in because most of the currents are coming in. So we'll do I2 plus 7 amps. Plus the current coming in here would be 3 times I2. It's a little cumbersome to include these subscripts. Normally if I was working this problem, I wouldn't include the subscripts here, but I just do so that we can be a little bit careful about distinguishing the two situations. So we'll have 7 amps plus, 3 I2. We're doing the current coming into it, so it's 3 I2 minus the node voltage here. Now the node voltage here, actually, we know what it is because if we set a reference voltage down here to be ground, then it'll be minus 3 I2 because it's the current flowing through this resistor times the resistance. So that's minus 3 I2. So 3 I2 minus 3 I2, so it's plus 3 I2. So that's the voltage drop from here to here divided by 2 ohms. Sorry. Yeah, that's potential divided by voltage. And that has to sum to 0 by KCL, so we can use this to solve for I2. So that's going to be 3 I2, so we're going to have a total of 4 I2 is equal to minus 7. That means that I2 is equal to minus 7/4. And that means that current, total current, which is I1 plus I2. Actually, let's rearrange here to solve for I1. Didn't quite finish that up. So over here, we're going to do multiply both sides by 5. We're going to get 24 minus 3I is equal to 5I. And that means that I is going to bring this over, you get 8I, and then divide through, and you're going to get 3. So this is going to be 3 amps minus 7/4, or 12 minus 7, which is 5/4 amps. All right. And that's how it's done.